All right, so now we are on to question number 2 on the final exam. So first of all, there will be a little glitch we're going to talk about here of way we've talked about it so far that leads you to an incorrect answer I'll still take. And then there is a second way that should be done that will get you the right answer, which you should be aware of going into the AP exam. All right, so let's start with the easy one. What is the velocity to hit the ground to reach that height? Did he leave the ground to reach that height? Okay, so we have someone on a pogo stick, okay, and they go up, all right, and they're on these springs, okay? So we want to know a few things. First of all, we know H, okay, and we want to know V. Okay, so in order to do that, we're going to have to do, okay, so there's no friction, so we don't have to worry about any of those things. So we can talk about our PE1 plus KE1 equals PE2 plus KE2. There's one object, it's not hitting anything else, there's no friction, so we don't have to worry about any of those other points. There will be at like E0 or E3, I guess, there will be a spring, okay? But while in the air, we have 1 and 2, it's there's no springs present, okay? So you could do, but those are quickly going to just disappear. Okay, so at point 1, they have left the spring. They are next to the ground. They are moving. At point 2, they are up high. They are no longer moving, and they're still not touching the spring. Okay, so we can, using the height, find the velocity. Okay, so we're going to do equals. All right, so we know a lot of these things already, and in fact, they're going to cancel out as well. Kilograms, 0.8, and H is 3.06. Okay, so if we plug that all in and we take the square root, we should get our velocity equals 7.74 meters per second. Okay, now what is his acceleration or deceleration? It will be a negative acceleration if he lands with the same velocity and comes to rest within 0.4 meters. And yes, this is supposed to be a distance, not a time. Okay, so we know d equals 0.4 meters. Okay, we could call that the change in d if we want. And we know v naught equals 7.74 meters per second. V1 equals 0. And we want to find acceleration. Okay, so there's no time here. So our favorite does not work. Okay, and that does not work. Okay, what does work is that one. Okay, does not have time. We have distance, we have initial velocity, we have final velocity. The only thing we're missing is what we're looking for. So that works out great. Okay, so that's going to be 0 squared equals 7.74 squared plus 2, what we're looking for, times 0.4. Okay, all right, we plug all of that in and we get an acceleration of 75 meters per second. Okay, because I said acceleration or deceleration, you could say negative acceleration or positive deceleration. Okay, so that is the acceleration here. Now, this is his average. Okay. And we've always dealt with things like in the air or on a straight surface. Even if it's a ramp, it's straight, it's not curved or anything like that. This is not true for springs, okay? So random aside here, if we were going to do our graph, okay, of distance and acceleration, okay, this be fairly similar to acceleration versus time, by the way, okay? We've always done things where they're blocks, okay? But on this one, right, F equals negative kx, the acceleration keeps changing. So what we found was the average, okay, which is the answer I'm expecting, all right, which would actually be squared. But if we were to try to plug it into this one, we really should be using the final acceleration. I'm going to work through this like this was a constant acceleration for our answer, but you'll notice something happens along the way that demonstrates that we really should have used the final acceleration, which would have been just like going down a ramp. It should have been twice this number, okay? So now we have the stopping force. All right, was the stopping force inside the pogo stick. So this is going to be F equals ma. We know A, we know M, so we can just do kilograms times 75 meters per second squared. Again, I said stopping force, so I'm going to use the positive number for this. Okay, so this is about 470 newtons. Okay. Again, this is the average. Okay. At the very beginning, when it touches the spring, it gets very little force, and then it gets more and more as you go down, which is where things are going to get tricky over here. Okay. Again, I'm just going to use and assume that all of you did it like it was a constant force, and that I'll be accepting that as our answer. Okay, because next up, if we want to know the spring constant, okay, now we know the force. And we know it was compressed. Okay, so K would, in this case, would be 12 to 30 newtons per meter. Okay, that would be if this was, if instead of having this drawing, it had gone like this. Okay, so in fact, this should be twice that size because it was twice the force at the 0.4 meter mark. Okay, so this was the, what did I say acceleration was? 75, but it should have been really 150 down here. Okay, again, I'm going to take this for this test. We didn't go into as much detail as I had hoped during the year, and so I realized we're going to see that problem. I don't want to punish you for the parts I did not get to. Okay, so, but if we have this, whatever number you take there, you're going to want to put in to here, how much energy did the spring absorb? Okay, and that gets us our final answer here. Now, if you're really on top of things, you would have noticed that this number, okay, it does not match up with what this energy was. That energy equaled, what was that? 1949 joules. Okay, if you had multiplied all those numbers out. Okay. So that number should have been equal to this number if we had used final force instead of the average force. The final force to find our K and our new K to find this. That would have doubled these numbers and brought us back up to here. Okay. All right, so that answers question number 2.